I'm Ennemcien. Now we have to see combinations of various components connected across an AC source. First one is RL combination, resistance and inductance coil in series, and the combination is connected to an AC source. The RMS value of the AC source supplied voltage is V. This is split up into two. RMS voltage across the resistance is VR. RMS value of voltage is VL. If the applied voltage is DC, of course, V will be equal to VR plus VL. But here the case is different. Now, we use vector method. Vector method is easiest method. It requires a little space and time to solve circuit problems of AC. We choose a horizontal line as the baseline and we take it the line representing current vector. That is baseline. Now, we have seen that in resistance, voltage and current are in the same phase, or phase difference between current and voltage is zero. So we must mark VR, voltage across the resistance, on the same baseline. Angle between these I vector and VR vector must be zero. That is, VR vector must be drawn on the same line, say vector OA. That is VR. Then in inductance coil, voltage leads on current by 90 degree. So we draw VL perpendicular to the baseline, OB. Then the applied voltage or total voltage of sum of VR and VL is given by parallelogram law. You complete, here this is a rectangle, then the diagonal OC represents the sum of these two voltages. Let it be V. Then this V makes an angle phi with the baseline or current line. That means in RL circuit, voltage leads on current by a phase phi. That is not 90 degree, it is less than 90 degree. Now we can make calculations. Now, this is a right angle triangle, so that we can write OC square equals OA square plus AB square equals OA square plus AZ is equal to OB. So OB square. OC square is V square equals VR square plus VL square. Let it be equation number 1. Now VR equals I into R. VL equals I into XL. Remember the inductive circuit. IXL, that is I into XL is omega into L. Then the total voltage V must be equal to I into total reactance of this circuit or total resistance of the circuit. We denote it by the letter capital Z. Z is called total impedance of the circuit. Impedance is a combination of resistance and reactance. Then we substitute these values in equation 1. So V square is I square Z square equals VR square is I squared R square plus VL square is I square omega square L square. I square would go, then we get Z square equals R square plus omega square L square, or Z equals square root of R square plus omega. This is the formula for total impedance of RL circuit or series combination of R and L. Impedance formula. Okay, this is not R equals R plus omega L. Just you use Pythagoras theorem here. There is a difference between DC circuit and AC circuit. Then from the same triangle, we have to find out the phase difference between applied voltage and current. For that, you have to find phi. For this, take tan phi. Tan phi equals opposite side by adjacent side. This is equal to this, or VL by VR. That is tan phi. VL is I into omega L by VR is I into R, or tan phi equals omega L by R. That means phi is tan inverse omega L. Now you can construct a right angle triangle using R, Z and omega L, because this is Pythagoras theorem and the triangle will be like this. Base is always R. This is omega L. This is Z. This triangle is called impedance triangle. This is the phase difference. See this? Now you can write voltage and current equations. If the applied voltage, we have made these calculations using RMS values. So if you are asked to write the concerned equations, we can do like this. If the applied voltage is V equals V0 sin omega t, I should be I equals I0 sin omega t minus phi, because in this circuit, voltage leads on current by phi, or current lags behind voltage. That is why we have put in the equation for I a minus phi. Current lags behind the voltage. Or if you write I equals I0 sin omega t, then V should be written as V equals V0 sin omega t plus phi, where I0 equals V0 by Z. This is the analysis of RL circuit, or combination of resistance and inductance coil. We will discuss the rest of the circuits in the coming postings. Thank you.